Imagine if a propulsion system could be lighter, safer, and smarter. Take you on a new journey and allow you to unlock new possibilities on orbit. At IonX, we have redefined space propulsion. No complex-to-operate systems, no expensive fuels, no warm-up delays, but just simple design and immediate, efficient thrust whenever you need it.
Today, satellite operators need propulsion systems that are compact, efficient, powerful, and with production cost compatible with large-scale deployment. And that's exactly what we have developed at IonX.
We all use satellites' data on a daily basis, weather forecasts, positioning, or communications. Even scientific research on global warming depends on them. Our mission is clear: provide satellite operators with the best propulsion system possible to extend satellite lifetimes, enhance maneuverability, and unlock new revenue streams. Our thrusters provide precise orbital control, extending operational lifespans. This translates to richer datasets, maximized uptime, and greater revenue potential for satellite operators. Because securing the future of space exploration is not just about technology, it is also about responsibility.
Our thruster also gives the satellite the ability to maneuver during its mission so that it can avoid some terrible collisions. And we also give the ability to deorbit at the end of their life. They are not a threat anymore to the other operational satellites in orbit.
We unlock new missions profile, delayed deployment, agile repositioning, or even extending contracts. Our clients don't just plan for survival, they plan for growth.
The technology we are using is called electrospray or electrohydrodynamic, and it is a relatively new technology in the field of space propulsion. What's exciting beyond purely developing a new technology, which is always fascinating for engineers, is the fact that we currently don't know the limitation of that technology.
It is in human nature to go further, to push boundaries, to reach into the unknown. Our technology is not just for today's satellites. It is also built for tomorrow's missions across the solar system and beyond.
IonX technology relies on two main differentiating factors. First, the propellant that we are using with our thruster. It is an ionic liquid that is non-toxic, inert, non-pressurized, and produced in France with low cost of production. The second key differentiating factor is the efficiency of our propulsion system. In our 1U propulsion module, we are carrying less than 200 milliliters of liquid, and with that very low quantity, we can propel the spacecraft of roughly 50 kilograms in space for a few years.
Operational flexibility means you never stuck. Whether it's dodging debris, adjusting your orbit for better coverage, or extending your mission, our thrusters respond instantly without warm-up or complex sequences.
When a high voltage is applied between the propulsive slabs and the extractor grid, the ionic liquid forms a Taylor cone at each nanospike tip. From these cones, ions are extracted and accelerated at several hundred kilometers per second, creating a steady, controlled thrust. This technology is the result of over 4 decades of research at the French National Research Center of Nanoscience and Nanotechnology in Palaiseau. In 1984, Jacques Chirac began exploring the fundamentals of ion emission. Today, that knowledge fuels spacecraft in orbit. That scientific legacy drives IonX forward. We bridge cutting-edge nanomaterials research with real-world aerospace applications.
We ensure quality of our solution by partnering with leading institutions such as the French Space Agency and by building a team of highly experienced professionals.
Today, IonX team is composed of roughly 30 team members, and we have basically recruited the best in every single field that we need to tackle with this product. We have recruited across microfluidics, chemistry, electronics, mechanical design, thermal design, production, and industrialization.
All together, we're building smarter propulsion. We listen to operators and manufacturers.
We co-design the propulsion architectures with the customer mission team. Mass budget, mission duration, thrust profile. We tailor the stack accordingly without over-engineering.
For our customers, reliability is not optional, it is mission critical. We validate every thruster through rigorous environmental and performance testing.
We eliminate pressure systems, reduce safety constraints, and simplify testing.
Before going into space, our thrusters are tested on ground. That is called ground testing. They are testing in what we call vacuum chambers. There are metal tanks in which there are pumps that will decrease the pressure, thus recreating the space environment.
No pressure tanks means no launch risk certification. No specialist ground handling. It's safer, cheaper, and easier for everyone. You don't need a propulsion specialist on site, just bolt it on and go.
We are already in a position to deliver a few units per year, and we target a production ramp up to 40 units per year in 2027, and then 200 units per year in the next 5 years.
Beyond the pure technological development, what's really motivating for the team and myself is also to help and contribute to the development of space propulsion field for Europe and to help the continent maintain its leadership position in that system development, which is so critical for space missions.
Partner with us in shaping the future of space propulsion. Your journey begins today. ION-X. Unlock your on-orbit potential